Welcome to part 3 of the Advanced Quantum series. Today, we are coding the most famous quantum algorithm in history, Shor's factoring algorithm.
Modern internet security relies on the fact that multiplying two prime numbers is easy, but factoring their product back out takes classical supercomputers thousands of years. Shor's algorithm solves this in polynomial time, big O of log n cubed. Let's see how it works by factoring n and 15 using Qiskit 1.0.
Shor's algorithm doesn't guess factors directly, instead it turns factoring into a period-finding problem.
We pick a random number a equals 7. We want to find the period r of the function f of x equals 7 to the power of x mod 15.
The period is our equals for. Once we find a using quantum phase estimation, the prime factors are simply the greatest common divisor of a to the r over to minus 1 and n, and the greatest common divisor of a to the r over to plus 1 and n.
We will use 4 counting qubits to measure the phase and 4 target qubits to hold the state.
Now we run the circuit through the local sampler primitive to extract our period r.
The primary measurements yield states 00001004, 1008, and 1112.
Converting these binary values to phases k over 2 to the fourth give values of 0, 1/4, 1/2, and 3/4. The denominator reveals our period r equals 4.
Now we run classical post-processing.
The greatest common divisor of 7 to the 4 over 2 minus 1 and 15 equals 3. The greatest common divisor of 7 to the 4 over 2 plus 1 and 15 equals 5. We successfully factored 15 into 3 times 5 using a quantum computer.
That completes part 3 and wraps up our advanced quantum series. You have built Grover's search, quantum phase estimation, and Shor's algorithm using modern Qiskit 1.0.